Okay. All right. Okay. Assalamualaikum and welcome back to Dynamics ECS 429. We are now at week 6 and today is a 1 hour class. Today is 18th November 2021 and it's already 10:14 a.m. Okay, so for today's class, we're still going to talk on topic chapter 2, which is on kinetics of particle. Okay, so we're still in topic 2, but our topic is on kinetics of particles. Okay, so do you remember what you learned last week? So last week we learned about kinetics of particle by using a principle. What is the principle that we learned? Can you tell me, Akil? Akil, last week kita learn principle. Principle apa, Akil? Ha, Akil? Tadi jawab, Akil. Were you not here last week, Akil? Balkis, what was the principle that we learned last week, Balkis? Balkis? Principle of?
Principle of work and energy.
Yes. Nampak kertas tu. Berganti work and
Work and
energy. Apa you cari tu?
energy.
Yes, betul. So, last week
Work
kita
and energy.
yes, good. So
Work and
last week
energy.
yeah, you perli saya ke? You perli saya. Hello?
Line dia problem ada.
Yes, betul, work
Line
and
problem
energy. Oh, line dia problem. I ingatkan dia perli saya sebab I panggil nama dia banyak kali. Akil, Akil, Akil. So, dia pun jawab. Work energy, work energy, work energy. Okay, alright. Bukan jangan usik-usik saya pagi-pagi ni. Okay, alright. So, today we're still gonna do work and energy, but as promised, we're gonna do an example on a spring. Okay, so last week you did a lot of other types of examples due to weight, due to constant force, due to variable force. But today we're gonna do an example that is related to spring, so that you know the variety types of way to solve the different types of work of a force. Okay, so do you remember what is the formula for spring when you want to do work due to spring? Do you remember what is it? Work from 1 to 2 equals to what? Negative bracket 1 over 2 ks minus 1 over 2 ks. Okay, but it must be the final ks minus the initial ks, and don't forget to square root. Okay, that is the formula. Am I right? Am I right, guys?
Yes.
Betul ke?
Betul.
Okay, alright. So, okay, good. Betul, 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 betul. Okay.
Yes.
Alright. Okay. So now let's do one example on work and energy that involves a spring. Okay. All right. Let's see if you understand. Okay. Okay. Copy this question. Okay. Are you still copying this question? Let me know when you finish copying. Dah jawab dah tadi. Okay, alright. Okay, so okay. Now let's understand this question carefully. Now, so for this question, what we want to do is we want to solve this question using work and energy method. Okay, let's read this question together. Okay, alright. The platform P has a negligible mass and is tied down so that the 0.4 meter long cord keeps a 1 meter long spring. Okay, I didn't draw you the diagram yet because I want to draw together with you. Okay, so let's say we have a platform. Ni ada satu platform ni. Okay, so this platform has negligible mass and is tied down. Okay, so dia di tied down lah. Okay, so that 0.4 meter long cord keeps a 1 meter long spring compressed 0.6 meter. So sebenarnya ada apa? Ada spring bawah ni. Okay, so ni platform P. Okay, so cuba you read. The platform P has negligible mass. So platform P ni tak ada mass and is tied down. So dia diikat. So dia turun ke bawah lah, tied down. So that a 0.4 meter long cord keeps a 1 meter long spring compressed. So asalnya dia berapa panjang dia? Asalnya berapa? Asalnya 1 meter. So dia compress berapa banyak? Berapa banyak dia compress?
0.6.
So 0.6. So it means dia compress sebanyak 0.6 meters. So yang bawah ni adalah 0.4 meter. Faham tak? Faham tak this sentence? The platform P has negligible mass and is tied down so that the 0.4 meter long cord keep a 1 meter long spring compressed. Okay, so ni adalah spring lah. Okay, ni spring. Okay. And then spring ni ada stiffness Stiffness dia K equals to 200 Newton meter. Okay, ni spring Okay, so cord ni 0.4 meter. Okay, length cord ni. Okay, now when nothing is on the platform. So this happens when nothing is on the platform. Okay, so you clear, so I tulis. Nothing is on the platform. Okay, now. If a 2 kg block is placed on a platform, now cuba bayangkan there is now a 2 kilogram block which is placed on the platform and is released from rest after the platform is pushed down 0.1 meter. So you can imagine the same platform tapi dia dah push down berapa meter? Berapa banyak meter dia push down? Berapa banyak?
0.1.
So what happens to this height now? What do you think?
0.3.
Yes, that's correct. So now it has become 0. It is now 0.3 meters. So dia dah push down berapa banyak sebelumnya asal tadi? 0 ni 0.1 meter lah. Tapi sekarang ni dah ada apa? Block. So ada block ni. Okay. Okay. Alright. So this one is when it is released from rest, yeah? Okay. So now after the platform is pushed down 0.1 meter, now determine the maximum height h. So dia nak height h of the block rises in the air. So maksudnya dia lepaskan ni, block tu apa you rasa akan berlaku dekat block tu? What do you think will happen to the block? The block will terbang, yes, terbang. Tapi dia nak tahu apa? You faham tak dia nak tahu apa? Dia nak tahu the height. You understand? The height dia terbang lah. Okay, alright now. So, if you get and understand what this means, now we can do it. Alright now. So, do you remember the formula for work energy? It is T1 plus work equals to T2. Okay, now, what is the formula for kinetic energy? T1? T1 is the kinetic energy, 1 over 2 mv1 squared. And T2 is the same formula, but it will be the final velocity. Okay, so this will be the initial and this one will be the final. Okay, what is the initial velocity of the block?
0.
Why 0?
Rest.
Yes. So the initial velocity 1 is 0. Okay. Oops, kenapa dia? The initial velocity is 0. So it means our velocity T1 is 0. Now, what is the final velocity V2 when the block is released at the air at the highest point here? What is the velocity for this one? What do you think? Because they ask us to determine at the maximum height. So I'm asking you, bila V max, what is the velocity? Remember I pernah ajar, what is the velocity at maximum height?
0.
Yes, 0 also. So for T2, it will be 0. Okay? So it means T1 0, T2 also 0. Okay? Because you have to read the question, what they ask you. Because this question is a little bit tricky because they ask to determine at the maximum height. So the velocity is 0 because it starts from rest. And when it reaches the maximum height, the block reach the maximum height, the velocity is also 0. So for this question, T1 and T2 is 0. So right now we have to find H using the formula work. Okay, so what is the formula work for spring? What is the formula work for spring? Now, before that, you have to try to look at this question. What is the kind of work that can occur in this block, in this question? Now, work due to spring force. Betul tak? Kelas?
Betul.
Lagi satu, ada lagi satu.
Due to weight.
Yes. Work due to weight. Okay. So the key point is you must identify what is the kind of work that can occur in the question, and you must write down those important information so that you don't get it wrong. Okay, so now you have established work due to spring. So now let's write the formula work due to spring. What is the formula? I have written above here. That is the formula. Negative. Okay, what is the formula? Negative in bracket 1 over 2 ks 2 squared minus 1 over 2 ks 1 squared, close bracket. And then we also have another work due to weight. So it will also be negative w delta y. Do you remember delta y, this formula due to weight? Okay, now. Okay, so let's write the important information we have. Okay, now. What is the value for k? What is k?
100.
Huh?
200.
200. 200 what? 200 Newton meter. Don't forget the unit. Okay, what is the S? What is the final position length of the spring, sorry. Okay, now this is when it is released from rest. This is the final, right? Okay, what do you think the final height of the spring will be? What do you think?
1.
Why 1? Why 1?
Sebab dia kata panjang spring tu 1 meter.
Wrong. The answer is wrong. It's not 1. Now, can you look at this final diagram? What happened to the block? The block is up the air, right? Up in the air, kan? Now, what is the compressed height of the spring when there is nothing on the platform?
0.4.
Okay, this is 0.4. That is correct. Okay, and what is the original? The this one, the original height. The total height is 1 meter, right?
Yes.
So how much has it been compressed with nothing on the platform?
6.
Yes. So the answer is 0.6 squared. Okay. This one with nothing. You want the value of how much is compressed, how much it has short, this one, the length. You want this one, not the bottom one, okay? How much? Okay, so 0.6. Okay, now let me ask you this one pula. So K is the same, 200. Okay, what is the initial one? How much? From 1 meter, dia turun berapa banyak?
0.4.
No, berapa banyak dia turun from 1 meter? This one is 1 meter.
0.7.
So, yes, 0.7. Okay, 0.7. Okay, maybe because you see the diagram is in this way. Maybe if I change the diagram macam ni. Let's say this is the, so this is the unstretched. So basically you want to know this one. Okay, you want to know how much it has pushed, how much it has gone inside. Okay, all right. Okay, so 0.7, don't forget to put square. Okay, all right, so this one is done. Okay, it's okay. There are a lot of other questions related to this. You can try, and then when you try, you will understand better. So this one will be negative what? Mg. What is the mass of the block? W equals to mg. So if the mass is 2, G is 9.81. Can you calculate for me? 2 times 9.81 berapa?
19.62.
19.62, 62 Newton don't forget So this one is 19.62. Okay, now what is delta y? Now we're talking about the block. Okay, now we're talking about the block. Just now we were talking about the spring. Now we're talking about the block. Okay, so basically for this formula, what is the formula? Negative W delta Y. So you understand that delta Y is equals to what? Y2 minus Y1, right? So what do you think Y2 is?
H.
Yes, good. What is Y1? Okay, don't make a mistake this time. It has to be a perfect answer. What do you think Y1 is?
0.4.
0.3.
Yes. Aduh, dah nak cekik dah siapa yang jawab tu, that girl. Okay, 0.3. Okay. It's okay guys. This question is actually very good. You know why? Because dia very detail. Dia macam-macam S ada, delta Y ada, delta 1 ada. So it's okay. You can try to understand it again, look back at the question and do it again, or you can ask me right now. Okay. All right, good. So we have established that. So from this formula, you will need to put it in this formula, T1 plus work equals to T2. So it will be 0, okay? So write down the whole thing, okay? 0 plus, okay, so can you please get me the answer? Okay, calculate for me the answer. Okay. You need to put it back into the equation to show your understanding and then finally try to give me the answer H, okay? All right, again, don't make a mistake, don't make a mistake, okay? All right, it's either I will squeeze your neck, okay? Or I will give you thumbs up. Okay, quickly calculate for me and give me the answer.
Satu 1.56.
Hah? Hmm. Hah? Lagi?
0.29.
0 point?
29.
Hmm. Salah.
0.963.
Betul. Thumbs up to you. 0.963. Okay, jangan salah negatif positif tu Okay, jangan salah sebab dia negatif and then dalam tu multiply jadi positif balik. Okay. Right. This is the answer. Good. This is the answer, the correct answer. Okay.
Madam,
Hmm.
0.6 tu kena kuasa 2. Bukan tak ada ke?
Apa tak ada?
Oh.
Siapa
Okay.
cakap tak ada tu?
Okay, salah.
Adalah.
Saya ingat
Oh,
dah saya tulis formula tak ada. Saya
tu
salah
atas
pun.
tu ada. Berapa kali you tulis
Ada.
formula tu? Okay, formula ni kena faham. Dia apa? Formula dia adalah 1/2. K ini adalah stiffness of spring. S ni adalah displacement tu. Okay. Dia kuasa 2 atas tu. Yang 2 bawah ni adalah untuk final. Yang ni untuk initial. Okay. And then ada kuasa 2. Okay. Aduh. Siapa cakap tak ada? Siapa tu yang cakap tak ada tu?
Dia
Ya. Yes.
nak tanya boleh ke?
Boleh lah. Mestilah boleh.
Kenapa Y2 tu H, lepas tu Y1 tu 0.3?
Okey, sekarang ni formula ni, yang ni, formula ni is the due to weight, betul tak? So we're talking about the block. Okay. H adalah formula dia adalah, okay, look at this diagram dekat diagram ni formula dia adalah delta Y adalah Y2 minus Y1. Okay, Y2 adalah final dia. Final block ni dia dekat mana? Kat maximum height dia adalah H lah yang kita nak cari. Y1 ni bila block tu compress ni dia punya height berapa? From the ground 0.3. Nampak ni? Height ni. Bila blok tu berada dekat atas platform tu, dia punya height 0.3. Kan? Lepas tu bila blok tu terbang ke atas, kita tak tahu maximum height dia berapa. So H. Boleh tak? Faham tak? Ke masih tak faham? Okay. Boleh ke tak?
Faham, doktor.
Dia macam ni. Ni nampak. Ni anggaplah ni platform you. Nampak tak muka saya ni? Sekejap. Saya stop presenting. You tengok fokus kat saya. Besar-besar. Okay, nampak tak ni platform ni? Okay, ni anggaplah ni platform tu. Okay, lepas tu kita ada blok. Okay, kita nak ambil blok apa lah. Okay, anggaplah kita ambil blok ni. Ni blok tu. Phone tu lah blok tu kan. So, asal dia berapa? Asal dia berapa? Asal dia tinggi ni berapa? Tinggi ni asal dia 0.4. Lepas tu bila kita letak blok tu dia turun jadi berapa? 0.3. Lepas tu bila dia release apa jadi? Blok tu terbang. Tapi kita tak tahu apa maximum height dia. Okay. Boleh? Dah habis salin ni? Dah habis? Okay, saya share balik screen saya.
Ada, doktor.
Dah. Okay. Okay, alright now. Okay guys, so we are going to go back to another topic now. We have 20 minutes, so we can do that. So we're going to go to topic linear. We're going to do principle of linear impulse or momentum. Principle of linear impulse and momentum. Okay, so principle of linear impulse or momentum. Okay, do you remember what is the difference of principle of linear impulse, momentum and work energy? Work energy, dia focus on what? Displacement, betul tak? Kalau principle of linear and impulse, dia, what does it do? It solve velocity. Apa lagi? Force.
Time.
So you must understand the key word here is time. Okay, all right. So it's time. So what is the formula for principle of linear impulse and momentum? The formula is very simple, which is summation forces. Okay, mv. Okay, mv1 plus summation of integration of the force due to time, dt. So this one will be T1, this one will be T2 equals to linear momentum, which is summation of mv2. Okay, so this is the formula. Okay, so you remember this formula? Okay, now, do you remember formula for force? Formula for work energy is different. For this time, this is the linear momentum. Okay, this is the linear momentum. Okay, all right. The formula is different. Jangan confuse. Because sometimes student bila dia go to the exam, dia terbalik formula dengan work energy. It has happened before. I hope you are not the students that will make this kind of mistakes. So the formula is what? mv. Okay, all right. Now, and the force is due to time. The force. Okay, so okay, all right. So now that you understand this is the formula, now maybe we can start doing one simple question together because it's not that very difficult. Okay, right. Okay, Hold on, eh. Sekejap, saya tak selesa. Am I sharing my screen? Kan?
Ada.
Yes.
Ada. Okay. Alright now. Okay. Now, I'm going to do a same question. I'm going to pick a same question that we did last time, but we're going to solve it using principle of linear impulse and momentum. Please copy this question. Okay, let me know when you finish copying it.
Doktor.
Dah? Oh, cepat. Okay, now. So, the
Dah.
the 100 kilogram crate is originally at rest. Okay, so kita tahu it is 100 kilograms. Okay, and it is originally at rest on a smooth surface. Okay, if the towing force is 200 Newton, acting on an angle 45 degrees, is applied for 10 seconds, determine the final velocity and the normal force which the surface exerts on the crate. Okay, so benda ni adalah crate yang ni adalah orang panggil crate. Okay, so kat sini dia kata determine the velocity. So the question is determine the V. Tapi dekat sini dia bagi tahu at t equals to 10 seconds. So find the velocity at t equals to 10 seconds. Okay. Alright. And then dia bagi tahu ada towing force. So bila you nampak ada perkataan towing force ni, obviously you tahu ada force. So bila you tahu ada force, you tahu topik ni adalah topik kinetics. Okay. And then bila you nak solve this question using kinetics, mesti you fikir you nak guna Newton second law ke, work energy method ke, ataupun linear impulse and momentum. Okay. If you notice formula work and Newton second law, there is no time. formula work energy, there is no time. But formula apa yang ada time? Formula apa?
Linear impulse and momentum.
Yes, so you need to use principle of linear impulse and momentum. So the formula for principle of linear impulse and momentum is very simple. So you can write mv plus, okay, short form dia impulse macam ni equals to mv. Tapi this one will be initial, this one will be final. So mv1 will equal to what? It will be the summation forces of all the forces involved, okay, all the forces involved due to time. So this one will be T1, this one will be T2 equals to MV2. Okay, all right. Now, so let's find what is our MV1. Okay, what is the V1? What is our initial velocity? V1?
0.
0. Why? Because it starts from rest. So this is 0. So what is our V2? Do we have? Okay, this one is what we want to find. Okay, now let's list down all the information for the summation of forces that we have. Okay, now, all right. So now for this question, the summation of forces, if you want to put in this equation, it has to be in the same direction. So it means that the summation of forces, what I mean is F dt is either in the x direction or is either in the y direction. Okay, you cannot put all the forces in x and y in one equation. It doesn't make sense. Understand? It must be in the same direction. Okay, so but before that we need to do what? We need to draw the free body diagram, right? So let's draw the free body diagram. So we have a weight pointing down. What do we have else? We have a normal force. Okay, and we also have this towing force, so you need to resolve it. So how do you resolve it? This one will be 200 cos 45. This one will be 200 sine 45. Okay, now, so let's write down the equation. Okay, now, so okay, now, so for this question, if we want to have the velocity, okay, okay, we can solve it using the direction of the force to be in x direction. Let's say we want to be in x direction. Okay, so mv1 is 0. Okay, and then what do you have? Summation of forces in the f direction. Okay, in the x direction. Okay, let's say for this equation in the x direction. Okay, maybe I should write it down first so that you don't get confused. T1, T2, it will be fx dt equals to mv2. Okay, so I write it down again, 0. So what forces you have in the x direction? Can you tell me? What do you have?
200 cos
5.
5.
Yes, that's good. 200 cos 45. Okay, now because it's due to, apa is integration of time, you must multiply by the time, and the initial, since the initial time is 0 and starting time is 0, and then it wants at t equals to 10 seconds, so you just put 10 seconds. Okay, you remember for work energy. For work energy, you must put what? Here, the displacement, right? But now this formula is for time. So you must put the time, the final time, which is equal to 10. Do you understand, guys? You ingat tak when you did work energy, everything you have to multiply by the displacement kan? For this one, it has to be time, yeah? So don't forget, selalu student tertinggal that part. Lepas tu dia salah. Okay, so our mass tadi berapa? 100 kilograms. And then this one will be V2. So from here, what can you do? You can find V2, am I right? Can you please quickly find V2 for me? Fourteen.
Point 14.
Okay, betul? Meter per second. Okay. Alright. Good. So, now, now the next question is they ask you to find the normal force, right? So for the normal force, obviously for you to find the normal force, you have to use the summation of forces in what?
Y direction.
FY.
In the y direction. Okay, good. So what do you have in the y direction? So 0 is for mv1 plus. So what do you have in the y direction? Okay, write it down. Maybe you should write it down so you don't make mistake. F y dt equals to m. Okay, all right. Now, in the y direction, what is the okay? What is the velocity in the y direction? Do you have a velocity in the y direction? Okay, what is v1 in the y direction? 0. What is v2 in the y direction?
Kosong.
0. This one you must be clear. Don't make a mistake, because right now your crate is moving this way, right? You're moving this way. So V2, there is a value for Fx, okay? But V2 for Fy is 0. Okay? Siapa yang tak faham? Do you have a velocity in the y direction, guys? No. So it will be equal to 0. Okay. So now let's write down what is the equation in the y direction. So you must have a normal force lah. Okay. Look at the free body diagram balik. Mana free body diagram ni? Okay, what do you have? You have what?
Normal.
Normal multiply apa? Normal jangan lupa multiply.
10.
10. Apa lagi ada? Weight, betul tak weight? Minus M. Mass kita berapa? 100 times 81. 9.81 times 10 lagi. Lagi, do you have anything else? Ada kan? 200 apa?
55.
Jangan lupa multiply by 10. Jangan lupa 10 lagi 10 ni apa? Seconds Okay. And then equals to 0. So from here what you can do is you can find n. Can you find me n? Okay, dapat tak jawapannya? What is the answer, guys?
Eight, 3, 9.
Okay, betul. 839 Newton. Okay. All right. So basically, this is how you to solve it. Linear impulse of momentum is not difficult, but actually you can use the same problem using Newton's second law. What you do is you can find, if you want to use Newton's second law to solve the velocity, or you can use this formula V equals to V naught plus ACT, and then you can use the formula Fx equals to MAX. If you use this formula, you can get the same answer. Okay, but sometimes during the exam, sometimes it's they will highlight which method they ask you to ask you to do. If they say use impulse, you have to use this one. But if they do not mention, you can use the second law and this formula. You can use these two formulas to solve, like how I explained in the previous examples. If you don't believe me, you can try and then prove that you get the same answer. Okay? Boleh tak? It means that what I'm trying to say is if they ask you to find the normal force, you can use the same method to find the normal force using Newton's second law. But however, before that, you need to find the acceleration first. You need to find the acceleration first using this formula and then find it and then you can get it. Okay? All right, guys. Do you understand? For
Yes.
for normal force only, not for velocity. For normal force, okay? Because you have the velocity and then you have v, because you have v, you have v naught, you have t. So you find a, you put it inside here, you draw the free body diagram, and then you can find the normal force, okay? All right. So it means you can use other methods to solve this problem. But obviously, for this question, it looks easier if we use linear impulse and momentum. Okay, but the trick here, you must understand that if the force must be in that direction, don't consider x and y in both direction and include in one equation. It's the same with displacement. Remember, it's the same with work energy. Do you remember what I mentioned in work energy? You can only consider the force in the same direction as what? For work energy, you must consider the force in the same sense direction of what, guys? Remember work energy? Sorry, tak dengar apa dia? Are you talking, guys? What is the answer?
Displacement.
Yes, displacement. Okay, lambatnya jawab. Okay, so you understand that, eh? Okay, so there are a lot of examples yang for impulse and momentum. However, it's not difficult. It's just straightforward. Concept dia, draw the free body diagram, look at the forces in the direction, and then don't forget what your main purpose is, the integration due to time. So initial selalunya kosong, and what is the final time? So you have to just make sure you multiply by time lah, so that is easy lah. Okay, so that is all for topic impulse and momentum. And for a spring, I think we did a very comprehensive question on a spring. So supposedly if you do all the other questions that is in the tutorial, it will be easy for you and not that difficult. Okay, so I have another class at 11, so I need to stop this class right now. Can you please fill out the attendance, then only you can leave this group. You can only leave this group once you have filled in the attendance. So you can say, today in class, I learned an example for how to solve problems for using principle of work and energy method for a spring. And then we continue learning about linear impulse and momentum, where principle of linear impulse momentum, the main problem is to solve questions related to velocity, force and time. And the formula is mv plus integration of force due to time equals to mv2, something like that lah. Whatever you understand in your heart lah. So, but what you need to know is impulse is very simple. If you get a question, calculate time, automatically you know you need to find the using principle of impulse and momentum. Okay, all right, okay. So maybe because this is a 1 hour class, we don't have much time. Mungkin next week, you're gonna have a school break, kan? And then you're going to come back and then we're going to go to topic chapter 3. But however, for 2 hours, I'm going to also include some more questions on impulse so that you understand better and maybe more examples and application on it. Okay, so I will stop recording now right now. So can you fill in the attendance?